So this video is on WebAssign 7. Like I told you guys I'd make it now so we don't have to go over it in Zoom. So I'm just going to go over the basic points because it's not that hard, but you got to know what you're doing. So first it says here velocity of 46 feet per second. Its height in feet after t seconds is given by 46t minus 16t squared. Find the velocity when t equals 2. Okay, so it's thrown into the air with 46 feet per second, and this is its height, y equals 46 minus 16t squared. Find the velocity when t is equal to 2. So how fast is it going at t equals 2 seconds? Okay, and this is its height, and we know it started off at 46 feet per second. Okay, so the basic idea here is they use s, which is a little awkward, but whatever. They use s like down here for position, okay, or height. So here I guess they're using y. So sometimes they use s for position. And the rate of change of position, how fast your position changes, is the derivative, is the velocity. So the velocity is the rate of change of your position, is how fast your position changes. In this case, your position is y. So how fast you're going, velocity, is dy dt. The derivative of the height, the derivative is how fast your height is changing. Okay, so the position is y. They tell us that your height is minus 46t minus 16t squared. So we know how to take the derivative. You're supposed to plug it into the definition of the derivative. But that's a lot of work, the f of x plus h minus f of x squared. I also told you the power rule, which is fine to use here. If we want to find dy dt, which is the velocity, v is the velocity, dy dt, you just take the derivative of this, okay, which means you take the power, this is t to the 1, so 1 times 46, t to the 0. T to the 0 is equal to 1, anything to the 0 power is equal to 1. So that's just 46. And again, you should get used to that. If you have something like 46x or something, the derivative is just a number. The single variable by itself goes away when you take the derivative. Minus t squared, the derivative, put the 2 in front, multiply the 2 by 16, that's negative 32, take away 1, so that's minus 32t. Now notice, at t equals 0, the answer is 46, which is what they told us. They didn't have to tell us that. We can figure that out. When t is equal to 0, our velocity dy dt is 46, which is this. Okay, so I don't know why they said that. They didn't have to. Now they say find the velocity when t equals 2. So you just plug in 2 there. So when t equals 2, we have 46 minus 32 times 2. Looks like it's going to be a negative number, which means it's on its way down. So you throw something up, right? It starts off going up. It starts off at 46 feet per second up. But it looks like 2 seconds later, it's going to be on its way down. It's going to have a negative velocity. Usually you think up being positive and down being negative. So it has a negative velocity 2 seconds later. Okay, and you can do the math. You're going to have different numbers in 46, it doesn't matter. Okay, so that's the idea with velocities, okay? So the next one is very similar. They give you the displacement, which is a position, and the velocity is just ds dt. Now they're going to give us a bunch of stuff here to kind of get the feeling for it. So the average velocity over each time interval. So to figure out the average velocity over each time interval, you got to figure out how far it went and divide that by time. So where is it at 3? Where is it at 4? Subtract those two things and divide it by 1 second. Okay? So here it's only half a second. You divide it by a half a second. Where is it at 3.5? Where is it at 4? So where is it at 3? It would be its position at 3 is 3 squared, right? You just plug in 3 here, minus 9 times 3 plus 19. And the way you I'm going to write it like this. So that's s of 3. S of 4, its position at 4, is 4 squared minus 9 times 4 plus 19. Again, my numbers are 9 and 19. Yours might be different. Now you just subtract the two. So the average velocity, and typically you can represent average by a line over it, is s of 4 minus s of 3, how far it went. Right here, at 3 it was at whatever number this is. At 4 it's at whatever number this is. So how far did it go? It went that far, divided by the time, which is 1 second here, because 4 minus 3 is 1. And that's its average velocity, the distance divided by time. Now, the velocity might have been changing, but on the average between that time, it went wherever it was at 3 to wherever it was at 4, and it did that in 1 second. So you do the same thing for those. And then they say find the instantaneous velocity. That means how fast was it actually going at 4 seconds. And probably you could guess. All these things are right around 4, right? You could probably guess the number. But you could also just take the derivative here. So ds dt, the derivative, right? Derivative t squared is 2t. The derivative of minus 9t is minus 9. And the derivative of a constant is 0. That's another thing you should get rid of. What is the rate of change of a constant? By definition, constants don't change. 19 is always 19. So when you take the derivative of this, all constants, the derivative is 0. Derivative of the number in front of a t is just that number, minus 9, and then that would be 2t. And we can just plug in t equals 4 now. Right, what is the velocity when t equals 4? You plug in t equals 4, and you get, I would get, whatever, -1 or something. Okay, yeah, and be careful with negatives, by the way. Maybe it's going backwards here. Maybe its position at 4 seconds is smaller than its position at 3 seconds. So that's why it's always the second one minus the first one, because negatives can get you messed up there. So just be careful of that. Okay, that's that one. So again, you can do those for your own numbers. Okay, now here is real easy. They say find the derivative. If you know the rules, the power rule, that's trivial. If you had to plug it into f of x plus h minus f of x divided by h and square it all out and cancel out stuff, it'd be a lot more work. And that's what you're supposed to do here. They haven't taught us these rules yet. That's the next chapter, the power rule. So I don't mind if you do that. Obviously, I can't check your work here. But make sure you know how to do that. On tests and things, they want you to show your work. You have to show you know how to use the definition of the derivative. Really quickly, I'll show you what that means. That would be f of x plus h. Right, the definition of the derivative is as x approaches h, as h approaches 0, as h approaches 0, of f of x plus h minus f of x divided by h. So you got to plug in everywhere there's an x, you plug in x plus h, so 2 times x plus h squared minus 3 times x plus h. Get rid of this here. Plus 3 minus the function just the way it is, 2x squared minus 3x plus 3, divide all that by h, multiply all these things out, a lot of things will cancel, you eventually cancel the h in the bottom, and then you get the derivative. You get what's left over is the derivative. Okay, a lot easier to just use the power rule. But that's the idea, right? You have to show you can do all that work. And it's not that bad. It'd take me another minute maybe, but whatever. Okay, that's number 3. Super easy. And number 4, okay, this limit represents the derivative of some function. Okay, this is the derivative of some function at some number a. State such an f and an a. The number, so what they're doing here is, remember there's two ways to write the derivative. One way is the one I just did. The other way is the derivative at a point A. And that's the limit as x approaches A of f of x minus f at A divided by x minus A. Okay, that's the other definition of a derivative at a point A. So we just match up what's going on here, right? So we match up what's going on here. So obviously it looks like A is 3, because A there, those match. That's what A is. Our function is 2dx. The function at A is 8, I guess. They don't ask us that. Okay, they're just, again, there's 2 ways to write the derivative. There's that way, and then there's the h way. And remember, the h way is the limit as h approaches 0 of f of x plus h minus f of x divided by h. This is the more standard way. This gives you an x in it. Here we only know the derivative at a point. At a point. Here we actually get a formula for the derivative. with an x in it, and then we can plug in any point we want for the x. So this is the general way. This is the definition of the derivative as a function, they say. The derivative is a function because we have an x in it, and this is the derivative at a point, which is limited. Way better to find the function and then plug in for the point. Plug in x equals 3 instead of doing this and only finding it for x equals 3. But that still can be useful. So it's still there. Okay, so that's number 4. Now this is all about the meaning of the definition of the derivative. I'll let you figure those out. And remember, the definition of the derivative is the slope. So the derivative is the slope, which is how fast things change, how fast something is changing with time, right? The slope, this thing is not changing very fast with time. This thing is changing a lot with time. It's not necessarily time. It can be how it changes with distance. It doesn't have to be with respect to time. Oftentimes it is. The derivative is how fast something changes with time, because that's an interesting thing, like velocity, how fast something is moving with time or something. But it doesn't have to be time. But this is a big change, right? This is a small change. This is a negative change. It's going down. It's just all about understanding that, right? That the slope is the derivative, is how fast something is changing, whether it's positive, negative, not changing at all, right? Not changing at all is a constant slope, which means the derivative is 0. The derivative is 0 if it's not changing, and it's infinite change, which means the derivative is really undefined, infinite slope kind of thing. All right, so yes, and typically it's something units per time, or how something's changing per pound, or whatever. So you can think about that. Let's look at one more. Oh, what is this? So, okay, this is just dealing with limits. You have to use your limit skills to figure these things out. I think you can do that. Good stuff here. Again here, they have positions as a function of time, so this rate of change is the derivative. So again, you take the derivative with respect to time as the rate of change. Yeah, I think you got that. Okay, that's the beginning, at least, of WebAssign 7. You can always look in the book too. I think it's sections 2.7 and 2.8. They always tell you at the top what sections to look at. They have lots of examples in the book, and the formulas they go. It just pretty much follows the book. So I really suggest you look at that too. Okay, good. Not too bad. And hopefully that helps you get most of it done.